Section 4.4, Probability with Complements, Unions, and Mutually Exclusive Events, Video 1. We will go over the following objective. Compute the probabilities of the complements of events. Probability of complements. Definition. Given event A, the complement of event A consists of the outcomes from the sample space that are not part of event A. Calculating probabilities of complements. Given event A, the probability of the complement of A, notated as the probability of A bar, can be calculated in the following three ways. 1. The probability of the complement of A equals the number of outcomes that are not in A divided by the number of outcomes in S, where S is the sample space. 2. The probability of the complement of A equals 1 minus the number of outcomes that are in A divided by the number of outcomes that are in S, where S is the sample space. 3. The probability of the complement of A equals 1 minus the probability of A. For the following examples, I will use one of the three ways to calculate the probability of complements. I will say, using number 1, 2, or 3 from the blue box to refer to one of the three ways to calculate probability of complements. Example 1. Using a standard 52 card deck. A. Find the probability of not choosing an ace. B. Find the probability of not selecting a red 7, 8, 9, or 10. So, for A, the probability of not choosing an ace can be found using number 2 from our blue box. So first we need to find out how many aces are in a 52 card deck. There are 4 aces out of the 52 cards in a standard deck. So using number 2 from the blue box, I would say 1 minus 4 out of 52. So we're subtracting the probability of choosing an ace out of 1, which would give us 48 out of 52. This reduces to 12 out of 13. So the probability of not choosing an ace would be 12/13. B. The probability of not selecting a red 7, 8, 9, or 10 can be found using number 2 from our blue box. First, we need to find out how many red 7s, 8s, 9s, and 10s there are. Well, there are 2 red 7s, 2 red 8s, 2 red 9s, and 2 red 10s for a total of 8 cards out of the standard 52 card deck. So we need to subtract from 1 the 8 out of 52 cards from a standard 52 card deck. So 1 minus the probability of selecting a red 7, 8, 9, or 10 would be 44 out of 52. This would reduce to 11/13. So the probability of not selecting a red 7, 8, 9, or 10 would be 11/13. Example 2. Using a 6-sided die. A. Find the probability of not rolling an odd number. B. Find the probability of not rolling an even number greater than 3. So for part A, the probability of not rolling an odd. Well, there are 3 odd numbers, that is 1, 3, and 5. So the probability of not rolling an odd number would be the even numbers, which would be 2, 4, and 6. Using number 1 from our blue box, there would be 3 even numbers out of the 6 numbers. So the probability of not rolling an odd would be 3/6, which reduces to 1/2. B. The probability of not rolling an even number greater than 3. So the probability of not rolling an even number greater than 3 could be found using number 2 from our blue box. So there are 2 numbers that are even numbers greater than 3. They are 4 and 6. So I need to find 1 minus 2, 6 The 2, 6 represents the probability of rolling a 4 and 6. This would give us a probability of 4, 6, which reduces to 2/3. So the probability of not rolling an even number greater than 3 would be 2/3. Example 3. Using the given spinner, find the probability of not landing on red. The probability of not landing on red. We can use number 1 from our blue box, so we need to find the probability of not landing on a red. That would be 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. So the probability of not landing on red would be 6/8, which reduces to 3/4. Example 4. If the probability of going to the arcade today is 27/100, what is the probability of not going to the arcade? Using number 3 from our blue box, we can find the probability of not going to the arcade by saying 1 subtracted by the probability of going to the arcade. 1 minus 27/100 would be 73/100. So the probability of not going to the arcade would be 73/100. Example 5. A. Using a standard 52 card deck, find the probability of not selecting a red or black card. B. Using a 6-sided die, find the probability of not rolling a number less than 0. So for part A, the probability of not selecting a red or black card could be found using number 2 from our blue box. So that is 1 minus the probability of selecting a red or black card. The probability of selecting a red or black card is 100% or 1. So 1 minus 1 would be 0. So the probability of not selecting a red or black card would be 0. B. Using a 6-sided die, find the probability of not rolling a number less than 0. So the probability of not rolling a number less than 0 can be found using number 2 from our blue box. So the probability of rolling a number less than 0 is 0. No number on a die is less than 0. So 1 minus the probability of rolling a number less than 0 would be 1. So the probability of not rolling a number less than 0 would be 1. Note, the sum of all probabilities from the outcomes in a sample space is 1. Thus, the sum of the probabilities of an event and its complement will always be 1 or 100%. This concludes example 5.